Hi guys and gals and kittens, and welcome to the I Need a Magic show. So for a couple of months now I've been speaking about how superior Hyperlambda is to traditional programming without really showing what Hyperlambda actually is or how it's tied together. In this video I'm going to try to correct this. So first of all, when you want to play with Hyperlambda and teach yourself Hyperlambda, the smartest place to start out is in Manage and Hyperlambda Playground. When you come here, you can actually load a bunch of like pre-declared snippets that illustrates some specific concept related to Hyperlambda by using and illustrating how slots work or how snippets work. You can also save your own snippets when you have created some particular useful snippet and you want to like reuse it later. Now, first of all, Hyperlambda is technically not a programming language, even though it happens to be capable of executing any type of functionality a traditional programming language can execute. It's actually a relational file format. Now, if I remove the comments here, and by the way, Hyperlambda has support for both C-style comments and C++ single line comments. If I remove these comments here now, you will see that this particular code has 17 lines of code, .folder, .lock, .files, and then it invokes this slot unwrap. You see, in Hyperlambda, there is no separation between variables and functions, if you wish. However, by convention, the execution engine will look to see if a node's name starts out with a dot. If it does, it's going to ignore it. This allows us to write .folder becoming like a variable, if you wish, for the code. These are basically nodes. Then you see a node has a name here, the name being .folder. Then there is a comma, and then there is a value. Now, by default, the value of every single node is string. And you can actually type declare a node if I write .foo, string, howdy world. And this is the exact same as this thing, because the string type declaration is the default one. But you can provide additional type declarations such as int 57 or decimal 57.5, etc., etc. And you do this by injecting the type declaration in between the node's name and the node's value with a colon on each side of the type declaration. So Hyperlambda is just a tree structure, really. So let's look at what that means. If I write .data, foo1, bar1, foo2, bar2, foo3, bar3. What I'm doing here now is that I'm declaring a graph object or a tree structure. First of all, there's an invisible node 0 here that you cannot see that becomes the host for my Hyperlambda code. This node 0 has one child node. The name of that node, child node is .data. Then at the end of this line, I add 1, 2, 3 spaces. This opens up the children declaration for this particular node. And a node in Hyperlambda is a name, and it's a value, and it's a children collection. So that differs from the way JSON is just a key value collection. And it's very important to emphasize that Hyperlambda is not a key value collection, it's a name value collection. Because what that implies that I can have several instances of nodes at the same scope as a children collection of another node with the same name without having the second one overwrite the first one. You cannot do that in JSON, so that is crucial to emphasize. So what I've done now, I've got one .data node with 3 children, being children foo1, foo2, foo3, having values of bar1, 2, and 3. So now I can write slots that are referencing my node hierarchy for each :x: at dp /hash set value :x: at .dp data hash dot for each was here. Now if I execute this code, you will see that the values of every single children node of the .data segment has now changed their values. So this is how you operate with variables, if you wish, but I can also change the name of the node, which is crucial when it comes to its meta-programming capabilities, allowing me to dynamically construct node hierarchies that are later actually executed. So this is a crucial element of its meta-programming capabilities. Now, if you want to see a little bit more complex code, so let's do data.connect magic data.read table, or actually let's do select all from log entries limit 10. See what this does. And as you can see now, I'm selecting log items from my database, right? And I get the result here as a list of records with each individual field repeated on each individual value returned from my database. I can also do hp.get. And what these basically are, they are slots. That's the way I refer to them as, but you might want to think of them as like Hyperlambda functions. So let's have a look at how these guys are specifically implemented. Now, if we go back to our for each example here, which we started with, so now let's do the set value here. So now we're looking at the for each loop. We're going to look at how that is implemented in C# to understand the relationship between the CLR and C# on the one hand and Hyperlambda on the other hand. So let's open up VS Code here now. Let's expand magic closed, plugins, magic lambda, magic.lambda. Then let's do loops, and then let's have a look at the for each loop here and how it is implemented. So you see, first of all, it implements an interface called iSlot, right? And then it provides an attribute that contains a field whose name is name, and the value of that attribute is for each. This is how we declare that we have a slot in C# that the Hyperlambda parser can actually execute. And if I now go back here now, and I hold down function and control and click space on my Mac, and that is Alt space, I think, on Windows, if I'm not completely mistaken, I can write for dash, and as you see, the autocompleter is capable of dynamically traversing all the slots within my application domain, return this to the front end, allowing me to get auto-completion on slot invocations, like I do here. Now here you will see the way that this particular slot happens to be implemented, where you can see it's basically creating for each loop, taking an expression as its input and executing its lambda object once for each node returned by my expression. And the expression parts here is kind of like important. If you see here now, if you remember, we just spoke about some few minutes ago how we can declare a type for a node's value. Well, this is a special type declaration that declares that this thing here is basically an expression. What the alpha here means, it means find the first node upwards in the hierarchy whose name is .data, which of course will yield this guy. Then the asterisk here basically says return all children from the previous result set. Now this is one iterator and this is another iterator. And iterators are separated by slash the way we see here in these two expressions. Now this alpha.dp, if you look at the C# code here, you will see that it actually dynamically injects a .dp node into the lambda object as it is executing it with the currently iterated node by reference. This pound sign here basically means take the value of that node that you returned here in .dp and transform it into a node, cast it, if you wish, into a node, and let me use that node. So basically what's happening here now is that the for each will iterate through each of these nodes, pass in one node at a time as it is executing its lambda object. That node we can reference using this particular expression, allowing us to change the value of the original node by reference, right? So now a lot of people are criticizing me in these videos because they're claiming that, you know, yeah, simple CRUD, okay, create something complex in Hyperlambda. Okay. So let me create something complex. You see here this folder, and if you go into HyperID and click System Files, for God's sake, don't edit any of the red files, right? However, if you now look at, for instance, OpenAI, and we look at, let's say, chat.get.hl, then I go to iniro.io, and I click this chatbot button, and I say hi to it, then all of a sudden you will realize that the entirety of the magic middleware is actually implemented in Hyperlambda itself. And this happens to be the chat-HTTP endpoint. And if you can see here, you will see that it ends with .get and .hl. And then it is also inside of the system folder. Now, if I create a similar file here inside of modules, and I create my own module, I call it howdy, and then I create a new file inside of my howdy folder. Where did it end up? And I name that file world.get.hl. Then basically this becomes an HTTP GET endpoint whose implementation will be Hyperlambda code. So now that we've spoken about the basics of Hyperlambda, hopefully it makes a little bit more sense exactly what Hyperlambda is and how it's actually working. Technically, I need to emphasize Hyperlambda is not a programming language. It's actually a relational file format allowing you to declare tree structures or graph objects. Such graph objects happens to be very good at describing functionality or executable snippets of code. And there is absolutely nothing you can do in C# that I cannot do, at the very least in theory, in Hyperlambda, even though it's not technically a programming language. Thank you for watching. Have a nice day.